Hi there, folks. Today we're looking at triangle congruence by angle, side angle, and angle, angle, side. So these are two more in addition to the ones we've already talked about. Remember, we had side, 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 and side, angle, side. Side, side, side is the obvious one. It's all of the sides matching up. Side, angle, side, remember, it's two sides with the angle in between. And so if we kind of apply that same logic here, angle, side, angle, well, it's kind of how it sounds. It's two angles with the side that's in between. Okay, so angle, side, angle. If two angles and the included side of one triangle are congruent to two angles and the included side of the other triangle, then the triangles are congruent. And again, whatever two angles we had, it has to be the side kind of connecting those two angles, the side in between those two angles, all right? So it's the one that connects the two, all right? We have to have it matched up that way. So kind of keep that in mind. And then you can kind of guess the angle, angle, side is going to be two angles followed by the side, and we'll talk about that one in a moment. But if we look at something like this guy, all right, it says given AC is perpendicular to AB, BD is perpendicular to CD, AB is congruent to DC, and AB is parallel to DC. All right, so the first thing I'm going to do is I'm going to label all this stuff because it really helps to kind of see this visually on the picture. So AC is perpendicular to AB. And you can do that by just putting a little box there to indicate that that's right angle. BD is perpendicular to CD. So once again, I'm going to put a little box here. AB is congruent to DC. So these guys are congruent. And then AB is parallel to DC. So AB is parallel to DC. So those are parallel. Okay? And so from here, we kind of have to start looking at this thing. And the reason it gives us the parallel and perpendicular lines, remember, when we have parallel lines, we know a lot about the angles. So we kind of want to start thinking along those lines, kind of reaching back to those parallel line, those properties of the angles, all right? And so now we want to prove that these two triangles are congruent. I already have one of the sides congruent. And the other thing here is, it was kind of arbitrary where I drew this box. I could have put the box here to show that that's congruent, all right? Or so that those are perpendicular, all right? Or here, all right? I chose to put it in a specific spot, but maybe it would be better if I showed it there, okay? And so you're probably looking at this already saying that the angle there at A and the angle there at D, well, those are the same because they're right angles. We can't jump right out and say that. All right, that could be maybe our first step. So hopefully you're already thinking along those lines, just looking at the labels that we've put here. Okay, so let's go statements and reasons. Let's talk about what I know. I'm going to start with what I know in terms of what they told me I know. So always start with the given. And you don't have to start with all the given. You can kind of pepper it in as you need it. I always just prefer to get it out of the way. Oops, that was congruent. I can't even copy the given down right. Oh man, there's not much hope for me. Okay, there we go. So that's all the stuff that's given. So I say given. And then, yeah, right away, when you look at this thing, and, this could be broken down very easily into multiple steps, all right? I could say that, well, ABC, angle ABC is a right angle, and angle BDC is a right angle, all right? And that's really what I know. I know those are right angles because of the whole perpendicular lines thing. Let's see, BAC is right angle. Likewise, actually, let me state it this way so it's a little less to write. BDC are right angles. Okay? And I can say that because that's the definition of perpendicular lines. And now from here, I could say that the two things are congruent. And here's the thing, depending on the teacher, in terms of a reasonable justification, they may allow you to go right to saying that these two things are congruent. It's that depends on how picky the teacher is going to be. When you talk about the exact letter of the law here, technically I should have that little step in between, but most teachers might not require you to do that. You could probably go right to saying these are congruent because they're right angles, all right? Messing up my color coordination. And that's because all right angles are congruent. Again, your teacher might not require that step 2. You can just look at it and say, all right, we know they're right angles, reasonable justification, all right? And then from here, so now I have two sides that are congruent. I have an angle that's congruent because of the right angles. Maybe I want to look for another angle here. And so let's talk about the last thing that I have here. So I've already used the perpendicular lines that were in the given. I've already got those sides that are congruent. The only thing I haven't really used are the parallel lines. So if I think about the parallel lines, and again, if you ignore kind of pieces of this thing and just kind of think about AB up here and CD down here, and then think about one of these lines as the transversal, maybe this one going across as CB. If these are parallel lines, you know a lot about these different angles. Like you know that this angle is congruent to this angle. And you know that these two angles are congruent, okay? You know that to some of these exterior angles, that this guy is congruent to this guy, all right? And that these two angles are congruent, all right? So we know a lot about that. Really, the ones that probably make the most sense, think about which angles are actually inside. If I erase too much of it there, geez, ridiculous, Mr. Jansen. But if you kind of think about which angles from the picture are inside the triangle, it's these two. And if I translate that over here to the graph, it's this one and this one right here, okay? And I could easily say that those are congruent because those are same side interior angles, and they're congruent when I have parallel lines. And so that's angle ABC. And I can say that that's congruent to angle BCD. And that's because those are same side interior angles. And again, those are only congruent when I have parallel lines. Okay, so same side interior. Let me abbreviate. Angles of parallel lines are congruent. Notice I'm just writing that out almost like an if-then statement. If I have parallel lines, same side interior angles are congruent, I could do it as an if-then statement instead. All right. So now what I have, if I look back up the picture, I see two angles, all right, the right angle and the congruent angle from the parallel lines, and the side that kind of connects them. That's the side in between. In the other triangle, the two angles and the side in between. So I can say the two triangles are congruent because of angle, side, angle. It's the two angles with the side in between. Just copy down my proof statement, ACB. And I'm only copying down the proof statement exactly so that it matches. Because remember, you could label those triangles in different ways. I don't think your teacher would care if you had, triangle, ABC. You would just have to relabel the second piece as well. Just make sure it's labeled correctly in terms of the congruence. Okay, but that was angle, side, angle. All right. So again, I only need those three pieces. And it's because of the nature of kind of locking these angles in place and how it forces the lines then to be the same. Okay? That's why we have these postulates. And so if I look at something like this guy, it says which triangles are congruent by angle, side, angle. All right? And so again, by angle, side, angle, not angle, side, side, because that's not a thing. Not angle, angle, side, because we haven't really talked about that. Not side, side, side. It's asking which ones have two angles and the side in between. Well, and that's A and B for this one, okay? And because, again, it's these two angles, and the side that connects them is the side in between. It's these two angles, and the side that connects them is the side that's in between. This one over here, C doesn't work because it's these two angles, Well, this side is not in between those two angles. It's not the side that connects them, okay? If I look at this next one, this one's not a postulate. We're going to list it as a theorem this time, okay? So angle, angle, side. Angle, angle, side, if two angles followed by a side are congruent for each triangle, then the two triangles are congruent. That's what we're trying to prove this time. So we can't use that. We're going to prove that that is true, okay? And here's how we prove that. So this isn't just like kind of one of those things that we can just assume is going to be true. We're going to prove that it's true here, all right? So here I have two angles followed by the side, and notice that kind of order. As I move my way around the triangle, angle, angle, and then the following side. Angle, angle, and then the following side. We're going to prove that these two triangles are congruent. And then once we've done this, we can use angle, angle, side as much as we want after we prove that this works, okay? And so let's start with my statements and reasons here. We'll start with what's given. So in this one, I've got angle A and D are congruent. I've got angle B and B and E are congruent. And I've got that AC is congruent to DF. Whew, just squeezed it all in there. And that's given. Okay? So now think about what else I know here. All right? One of the very first things we had with triangles that we went through and proved was that if I have two angles that are the same, what do we know about the third angle? The third angle has to be the same. And that went back to the idea that these add up to 180. So if two out of the three things are the same, well, the third thing has to be the same in order to get that 180. And we proved that. And so what I can do here is I can say that angles C and F are congruent. And that's not really from anything that was given. That's a whole separate theorem that we had. So angle C is congruent to angle F. And that's that third angle is congruent kind of deal. And again, just state it this way. Say, hey, if two angles of triangle are congruent, then third angle is congruent. Okay? State it as an if-then statement if you're not sure. If you know that's a theorem, you know that's something that we've proven in the past, state it as an if-then statement, and we can use that. You don't have to remember the name, okay? And so now let me label this back up in the picture, because that's always good. So now look at what I have. Now that I have that third angle, I have one of the other methods for proving triangles are congruent that we've already talked about. I have two angles with the side that's in between. Look at this. This angle, and the side in between. This angle, and the side that's in between. Okay? And so I can prove that the two triangles are congruent. Triangle ABC is congruent to triangle DEF. And that's because of angle, side, angle. Okay? So now using angle, side, angle, I've just proven that when I had two angles followed by a side, that the triangles are congruent. So now I can use this anytime I want. Okay? Now that we've proven that that is true, I can use that as another tool to prove that triangles are congruent. Okay? So again, this is a theorem. It's something we can prove. It wasn't a postulate that we just assumed to be true based on what we're looking at. All right. If two angles and the excluded side of one triangle are congruent to two angles and the excluded side of another triangle, then the triangles are congruent. Again, it's about the order of things. Angle, angle, followed by a side, not the side in between. All right. These two triangles will be congruent. All right. So once again, if I look at these guys, let's determine a justification. I want to determine if the triangle is congruent and then justify how I know that they're congruent. Okay? And these are similar or the same examples that we did previously. Again, got 4 different examples, but maybe our justification will be different, or maybe we'll have more than one justification. Okay? So if I look at something like this guy, I've got two angles that are congruent. And look at the order here. If I kind of work my way around the triangle, this angle, then this angle. If I keep going, then a side. So it's angle, angle, side. This angle, then this angle. This would be the side that I'm looking at then. okay? And see, notice the order there is kind of important, because when we look at this first triangle, this side borders this angle. But in this one, this side borders this angle. And so this doesn't quite match up the way we wanted it to. And so with a couple of these, the order becomes really, really important. I can't make a justification here unless maybe I go this route. I could say that, well, I know that these angles are congruent. And I know that those angles are congruent because of the third angle. Well, now I could check some other things. I could say, oh, the 3 and the 2 with the angle in between, or the side in between. The 3 and the 2 with the side, still doesn't have the right one. And so, I try working my way around in different orders, but it just doesn't work out, okay? And so be really careful here. This is where students really make mistakes in terms of angle, angle, side, or angle, side, or side, angle, side, is the order is really important. As I look at the order of the pieces, the second triangle has to have the same pieces in the same order in order to use that as a justification, okay? So this one, I can't make a justification here. So for now, I'm going to say that they're not congruent, okay? Because I can't prove that they are, all right? If I look at this one, again, working your way around the triangle, see the 1 dash, then the angle, then the 2 dashes. Side, angle, side. So that's what I'm looking at over here. So start with the 1 dash, then the angle, then the 2 sides. And notice I can match that up the same way. 1 dash, angle, 2 dashes. 1 dash, angle, 2 dashes. Okay? It matches up in terms of the order, and that was side, angle, side. So I can say that these are congruent because of side, angle, side. Okay? Order becomes really important here. If I look at this one, and again, there's other information that we could kind of use here. Like I could use the fact that these are vertical angles, right? And so if I kind of look at just, let's start with just what's given here immediately. If I look at this, I say, okay, 1 dash, angle, 2 dashes. 1 dash, angle, 2 dashes. The order matches up. These are congruent because of side, angle, side again. But I can expand this one a little bit because these vertical angles, see, these vertical angles are congruent. So now think about it a little bit more and say, wait a minute, that means I could do angle, side, angle. Look at this. I've got this angle and this angle with the side in between. This angle, side in between. So I could use angle, side, angle as a justification for this as well. Along those same lines, once again, because of those angles here, ignore the side with 2 dashes. Angle, angle, followed by a side. And notice which one I started with. The 2 arcs, 1 arc, 1 dash. 2 arcs, 1 arc, 1 dash. Angle, angle, side. Okay? So I could also use that as a justification. All right? And that's all because I kind of threw those vertical angles in there, which is something else that we know. Okay? So that was kind of what we started with, and then we could tack these two on. We could use those as a justification if I show the vertical angles first. Okay? If I look at something like this guy, once again, I see all 3 sides are labeled, so the 3 sides match up, so I could say that these are congruent by side, side, side. And then I look at which angle is given. Well, maybe I'll look at this thing and say, okay, well, I've got the 2 dashes, angle in between with the 3 dashes. Here's the 2 dashes and the 3 dashes. Well, I don't have the angle in between. All right, so maybe I try going a different route, but as I look at this thing, I don't have any other angles here, so there's not really any other justification I can make. Okay, students will sometimes try to say, well, I have 2 sides and an angle. Well, the only ones that we have for 2 sides and an angle would be side, angle, side. Side, side, angle does not work. Okay, and that's kind of a lucky break for math teachers because we don't want you writing angle, side, side as your justification all the time and giggling to yourself. So that one does not work. There's a special situation that forces that to kind of not work, and we talk about that in terms of something swinging. Like if I had something like this guy versus the same thing going the other way, even though this could be the same angle, all right, we could have 2 different triangles, okay? That's not drawn very well, all right? But we kind of think about a short side that's kind of swinging back and forth. You could get the same angle, all right? You could have two sides in the same angle, but have a different triangle depending on where I swing that third side, okay? So the only ones we have are side, 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 angle, and angle, angle side, okay?